So we are going to continue from where we stopped the previous time. So, as I said previously, we'll focus on the injection side before we move over to the ejection side. And so let's get started. First of all, let's hide all the components that belongs to the ejection side. Cavity, this over cavity, pipets, as well. So the first thing was still to hide the parts. You don't need them for now. So the first thing is to create the screws that hold the cavity insert and the main plates, the main cavity plates, that's the P plates. So I've already made out use some sketches to create the bodies. So you just project them onto the surface once. Yeah, those it's cavity plates screws. I'm not seeing them, but I think if we hide the body, we'll see them. How to solid is the surface we want to place them on, and this. So these are the bodies before projects. Just project them onto the surface. The screw holes and the toilet pins as well. Toilet pins are the small ones, so the screw holes are the big side one. So finish sketch, we can turn on back our components. So I'm going to use GIM fasteners to create this. There are four numbers, so we go for socket head first, four sets. Select your points as usual. The 4 points, and they must be perfectly circular. That's 0. So this will be M12, and M12 screwed by 80 mm thread length. Let's go for 50 mm, 50 thread length. Okay, I'll wait for it to do its computation. So it's created is on the wrong side. It's placed the screws on the wrong side, so we have to edit the joints. So it's to the left side. Select that one. So flip. Think. Let's zoom in to see what you're actually doing is correct. Flip -12. Okay, that's the correct position it's supposed to be. Do the same thing for the rest. Flip -12. Edit trends. Flip -12. -12. So I just can do a quick session analysis to see if it actually engages the two components properly. I think that's okay. We can save this section analysis, this section view, because so we don't start creating so many section views. Yes, we need to learn how to manage the memory. So we move over to creating the door pins. So the door pins will be same thing and M12. Then ATMM as well. The door pins. You need to create them single individually. Also, it's secret. Place it at the wrong side. Still have to edit the joint again. -80. Okay, so that has been created. Also create it for the 4 as well. So I'm going to create all the door pins first. Yeah, all the door pins. So if I want to do the combine operation, I just do everything in one single operation. So I'm going to place the 4 door pins. And now for the last one. So I door pin. Let's see. Go back again to edit the joints. -18. So we can go back to our door number session view. So there we have the door pin, we have the screw. Yeah. So now let's do the combine operation. Also you know the then fasteners, create the screw and the cut body for the screw as well. So then open this up. I think I can select the door pins inside. So, so mistakenly it's a space bar because that usually used to be my previous shortcut for combine, but it's now a new command. So selected the body. Let's select the cavity place first. So then the door pins, think I can pick the door pins from here. And so okay, now this time I can hit spacebar or any one. I'm going to cut the cavity plates. Just holding this actually cut cavity inside now the cavity plates. And it's 1, 2, 3, 4. And let's should be able to select the door pins. Because if you want to talk of a door pins, it scrolly aligns the component in the Z direction. So the work of the door pins is to align the components in both the X and the Y direction. So you have proper alignment at the end of the day. Because not necessarily you must always use them for everything. That's where you need not only design, but where you need uh, high precision alignment in any component. You need high precision alignments. So you're supposed to use the pins. So now we are done fixing that. Sketches, and just hide the sketch, hide the school sketches. It's making everywhere look proud. So and this one, and this one. So we are done creating these the screws and the door pins for the cavity insert and the cavity plates. So next, I'm going to create the screw for the the one that will hold the top clamping plate and the main gravity plates. So for it, still be needing four sets because they have already known that. Select this one, select this one, and select this one. So for this one, according to our school standard, it's meant to be an M20 screen. You can as well check the Haskell catalog. You can request for it as well if you want to make purchase for the full version of AIG Mode Wizard, and you surely get it for free. Not just Haskell catalog, DME catalog as well, and also other other companies that we are using, that AIG Mode Wizard is using the standard. Also get the catalog. And wait for it to do its computation. And so luckily for us, this time the screws was positioned in the correct direction, so you don't need to make any joint edits, and it engages the two components properly. You can, let's save this session analysis as well. And rename this. So this one is supposed to be cavity insert screw. Then this cavity is clamp lid screw. And so you don't need to start creating multiple sensor analysis next time you need to look at those. So next what we're going to do is to create the guide pins for the mode. Let's create the guide pillars for the mode. So I need to turn off the top templates. So of course you go to alignment, still guide pins with color, and let's select this, select the top and see if it's actually created it in the correct position I need. Yes, we change the points. So this one we need diameter of 42 lengths. Then 295. Then 116. Oh, okay. Wait for it to do its computation. Just hope I selected the correct pointers. We need to Control Z and start and select the point again. Oh, it's created it in the wrong direction. Again, have to edit it. Just need to edit. I think if you go -10, it's not the correct position. Let's check. Oh, that's not the correct position. Let's edit joint again. Let me put it on 0. Yeah, so that's the way it's supposed to be. So that's the correct position in S. I need to turn on back all the B side of the mode because it's both aligns the A side and the B side. So we need just to see how far that goes. If it covers all the necessary places supposed to cover. Yeah, just okay. It covers up to this all through the support plates. So that length is okay. You can still even select a shorter length, but let's just go with it. So I already know the correct position. So let's leave this as 0. Look for the other joints, head joints, lip 0. Let's look for these joints, head joints, lip 0. So we are done with our guide pins. So next, I think we can create our cooling line first. I've already created the cooling line body. So let's cooling line 1. Also, what we need to do, let's hide the B side of the node again. Now just have the A plates. So we just combine them again. Use the cooling line, the multiple bodies. So we need to select them one after the other. Can't find the remaining. Let me hide the main A plates. Also, we can select this and this. Okay. And so let's do a section analysis to check if to ensure that the cooling line is not interfering with any screw or anything important. If not, we have to either readjust readjust the screw or readjust the cooling line. Also, it doesn't seem to be interfering with anything. Let's go down. It doesn't seem to be interfering with anything. Let me see if I can go down to get the door pin. The door pin is shorter, so it's not interfering. Yeah, so this is the point. This is the door pin point, so it's not interfering with the cooling line. I mean, this is not the most efficient cooling line. I mean, you can design much better cooling line, but this is just for demo purposes. So a quick what also how the cooling line flows is this is the this is the inlet side. This is the inlet of the cooling line. So when the coolant comes in, it flows through here. Then a hose then you are going to make use of a hose to loop this one and this one, then loop this one and this one. Then when it goes through here, and that hose will loop this one and this one, this one and this one. Then we have a sealing plug here to block the hot water from going to the inlet side. Then the the hot that's the outside coolant just flows out here, then this one flows out here. So that's how the coolant flows. So but for now, we've created the cooling line. As we can open this further. So it's caused the cavity plate as well. Uh, I'm trying to select the points. I think a sketch is blocking me. Turn off. Since this edge, a sketch is blocking me. On this bad point, let's just project the points. Hide. Hide the plate there. Create sketch. And I will project this one. Project this one. Project this one. Project this one. It's in the sketch. And if I should, then I select these 4 points. Turn the main place back on. Extend this and then we have a cut through. And I hide this back again. I project the inlets. This is okay. I wonder where this is like this. Let's take this out. Okay. It's showing me a warning. Uh, everything seems everything seems to be okay. So let's I need to cut the other side as well. So let me look for that sketch. That was the previous sketch. Then I can hide the main cavity plates. Then cut everything through. If I should, it's already 4 points. And take this here. Okay. So now we need to press pull it because we need space for the pipe lock to get in. Then apart from the pipe lock getting in, you also need so that you can use the tool to fit in the pipe plug without need of removing the main plates. It can be fitted from outside here. Right. Yes. So that's the main way. I think it was -3 we did the other one. So now let's press the front one as well. Use it. -3. Now let's turn on our cavity place back. So here we have the hose. So now let's move over to fitting the pipe locks. I don't need the A plates. So not less. So now let's use the inspect tool to see the actual size of that plug we need. And so that is diameter. Our cooling line is 14 mm. So we'll go back to utilities. Of course, we go to the cooling section. So 40 mm, so we need this as this 14. Okay, components are the origin. Yes, where the components. Let's create the first one. This first one, then we create I think 7. We remove all of them as well. Change the components. I'll drag it out to see the components. Capture position. J for joints. All the outlets need pipe plugs. So, and also I think we need to flip it. Yeah, that's faced correctly and is the correct size of pipe plug. So now let's just create how many of them here? This 3 plus 4, that's 7, then plus 2 at the front, that's 9. So we need 9 more pipe connector, sorry, not pipe plug, pipe connector. Uh, Now the reason why you can simply just use this one, do an area and place them at the point, but if you do that, the add-in won't recognize them as new components. So you need to create them individually before you place them. So you need more pipe connector. That's one. Again, two is 9 of them. 3, then 4, then 5, 6, 7, is 8, and 9. So now we can move all of them out. Uh, Step for move, hold down shift, drag everything out, point that all of them actually created the same position. No problem. It's going to select, it's not going to select everything at once, it's going to select each of them. Over here, flip. Is this hiding? J for giants. So let's do it for fix the pipe plugs in all the inlets. I mean the pipe connector, sorry. Don't know why I'm mixing them up. Pipe plug is to block plants from flowing outside. Pipe connector. J for joints. And so here's the last one. Now let's scan the big plates. Plate B back on. Sorry, plate A. I think there was like yeah, that I should. I have this one. think this cycle was not perfectly circular. So that's why I have that drawing, but it all seems to affect or have any geometrical effects. And we can check that. And so I don't really know what happened here, but there don't seems to be any geometrical effect on it. I think it was on the cooling line body. Also, we have our pipe plug, and I think it can enter here to fit in the pipe plug. If you like, if you want to make it more detailed, and the pipe connector, if you want to make it more detailed, you can add thread to it. So we need that section with you again because we need it to fit in the ceiling plug. Okay, so again we'll go to utilities, still on cooling, and we'll put the ceiling plug. Again, it's still on cooling. So let's put in ceiling plug. After our diameter is 14. So we'll need this size component at the origin. This section you might hide it, so let's rename this first so it makes work easier. So you can say part 1. So let's rename rename this as cooling line cooling line up because we need it sometimes. Let's install the ceiling plug. Hold on, so already created the components. And for move, I think I need to turn on the session view to be able to see its actual position. Tell me. J for joint again. Turn on back the session view. I think oh sorry. Oh wow, it's not. That's the correct place. Actually, yeah, this is the correct direction. Yeah, yeah, so that's that one is fitted. Also create and that one for this side. In components at the origin. My turn off this section of view. J for joints. And turn on back the session view to see that place. And just pick any circular points. It's facing the correct direction. Then draw the topher to here. Just much not as fitting one point there. Yeah. I think I need to go for no 100. I think that's just okay. So we're done with the cooling system. Next, we move over to the ejection system. So the first is to create the runner. So the gate and the runner. Uh, this is the runner. This is the gate. So B for combine. Chip 2 must still be active. This propeller also, I combine the propeller together with the runner because they are just basically the same entity. Hide this. Now we have our gates and our runner installed, created. And so plastic fluid. Here's the gates. Here's the runner. So now can go ahead with uh, placing the locating ring. So over to locating ring, um, select the size, ring 42. Components are the origin again. M for move, drag it out. Um, J, join it. I selected and place it at the points. Is it facing the correct direction? Yes, facing the correct direction. So so now we have our locating ring installed. So now I can add the top clamping place to create some bodies. So now I want to create the cut body. And we will use the surface tool to do that. So patch here. That's no, that didn't touch. Did I turn off bodies? No. It's actually I think it's green. Yeah, it's green. See if I can cycle component color. This I need this. I'm okay with this green, but I need this color to change. Anyways, I just I think we call these cycle components. We call this cycle components color. Yes, can only do this for components, not bodies. So we can't cycle this component color. But anyways, we don't limit that. So again, we also patch the top points. So now you can use loft to create that solid body. So move to left. Mm, I know this one. This one is a new body operation. Uh, I'm gonna hide those two. Now we have our cut body. So we need to turn on back our clamping plates, our top clamping plates to create the cutouts. So P for combine, like this, like this. Okay, let's hide it to see if everything uh, locating ring in the glass components we created. Everything seems to be just fine. So now let me still combine the B plates just in case some part of the locating ring entered the B plates. So that's that's all for now. Next is to create the screw holes for mounting the top clamping plates. So we need these points, projects. So make a offset of 4 offsets as make a offset of 6 mm. Then 2 screws will be enough of us. I did it equal string that. Let's try again. Let's make sure we have the center points. I didn't constrain it because I didn't draw any line to guide it, but it's perfectly at the middle. So we are done. We can finish sketch. So again, all of the iron fasteners again. So that's 2 of them. So we need to select them 1 M3 length would be 12 and trail length only 5 mm. Okay. Let's try to this computation and hope it places it in the correct direction. Let's flip it again. -3 and do the other one. M3 length 12 5 mm. Let's try to do this computation. It's created it in the wrong direction. So simply edit the joints. We can use the -3. Now we can combine that. And hide this sketch, hide this sketch. And we open this up. Open this screw holes before combined. And do them one after the other. Okay. Before combining again, first we need to put the locating range as well. Okay. We can hide the top borders and check if and inspect what we've just the locating ring 6. Okay. Inside. Trying to get center points for the screws. Yeah. Yeah, seems okay. So next is to create the screw. Since that body belongs, just check if anybody is on because of that blue something like a deep surface showing, but nothing seems to be on. Now we're gonna find in browser. Let's see if there's anything. Yeah, it's nothing but the top clamping plates. Let's try the locating ring again. Let's see if we have interference. No interference. So some graphical error. So now let's create the sprue. Sprue is an injection component. So we move over to the injection side. I need this one. Components are the origin and for moves. Drag this out. Capture deletion. J for joints. Move the top surface. And we need it below this point. So again, we can't find it. You don't seem to select the correct points. So conscious said that let me just hide the test hide the top clamping plate so we get the bottom of the hide the top interface so I get the locating ring, the bottom of the locating ring because that's where it's supposed to be. I think what happened is why it's being covered is because it's almost a surface, just a surface that's is blocking its the top component surface that's blocking it. Yeah, yeah, that's it. So it's fitted in the correct position. So when we create a cut body to open up that and what if or and the good thing is that it just goes through the runner. So that's kind of advantage we have of using this size of sprue. So let's go ahead with creating the when we cut body for this sprue. Add the top clamping plates, add the locating ring, add the locating ring, move over to surface, patch this into patch here, then offset, and then you need to switch. Okay, then patch the top. So now we can create a left. Solid left. I need to hide the sprue so it gets the surface. I'm not getting the surface is not perfectly is not plain. So I think that's why it's finding it difficult to see it as a profile. It's cancelled this one. So let's see if we stitch them together. If we stitch them together, it's going to create a solid body for us. Over the surface stitch. You can just select the body here. Stitch. Okay. It's created a body. So we have our cut body as well. let's create for the can hide that and create for the channel, the cut body for the channel as well. Um, patch is how we people it to get our bottom. If it was the bottom, the end of the channel. Where is this located? Just need to off this, turn this off. Now we patch this. Yeah. Now we can simply create a loft. Loft this one. Loft a new body operation. And so uh, the way they made this screw, you can have 2 points for holding this the screw in place, but I'm going to use only one, but we still need to create, so we need to close up this one. I will use the other one down. This thing doesn't seem, it's not perfectly circular like the way it appears. Operation, in that case, operation you can use is offset face. So the part is, we're going to left, let's see if we can left these two surfaces together. Over below. Yeah. Right. And this. Select this. We have that body created. Now we still need to create for the other one. And green surface. Map offsets. Offset is not sorry. I just need to make an offset here. Then patch this. Then hide this blue. Then create a losses. Turn on that transparent. We've created or we cut by this unit. Now we can turn on that plate A. Pumping plate and cavity plate A. It's cavity plate B on. Yeah. Put it off. Top pumping plate is supposed to be on. So let's just creating because the cutouts. Select the top pumping plate first. We have 3 bodies. Yes, there are 3. This one. We are missing one that covers the top. I think is this one. Yeah. So there are 4 bodies. Okay. Can look at. Let's hide that here. So hide the surfaces. You can't view the channel because let's hide. Yeah, so now we now have our screw, but the top lamping plate is still blocking it. So I still need to open it now first. So how about when we're done? When we're done cutting everything. It's analysis coffee in cavity plates. Three, four. Analysis plate. Algebra case. And next session will be mm, the top one plates. The top one plate was is open, so there are no was no surface looking at those that I need to open it more because this is sir. And see our like bushings installed well. First checking because this I was confused by this fillet here, so I thought we selected something smaller than the actual size is supposed to be. And so everything is fine. So in the next episode we'll start working in the ejection site.